exponent on bottom, that means it would have been a positive exponent on top. If it was a negative exponent on top, that means it would have been a positive exponent on bottom. It just means some silly goose subtracted in the wrong order, all right? So same thing. I know that when I do this problem, if it was the reverse, x squared divided by x to the 6th, I know I should take the big exponent minus the little one, get 4, get a positive exponent, and put it back on the bottom where the bigger one was, right? So now I'm left with 1 over x to the 4th. But hey, maybe somebody totally forgot about the big exponent minus the little exponent, but they remembered to subtract, right? So somebody might have taken 2, the smaller exponent, subtracted 6, got negative 4, put it back on the top where the 2 was, and now they got x to the negative 4th as their answer. They're not necessarily wrong, they're just not finished. So I already know the answer to this problem is 1 over x to the 4th. So that means x to the negative 4th must equal that as well. So that means x to the negative 4th is really 1 over x to the positive 4th. So if an exponent was negative on the top, that means it would be positive on the bottom. So that is exponent rule number 4. To make a negative exponent positive, you move it, or you flip it, if you will. Move it to the bottom or move it to the top. Now, when I see a negative exponent in a problem, a lot of the times I'll work with it because I can add negative numbers, I can subtract negative numbers, I can even multiply negative numbers. I just know in my final answer, I'm not leaving any exponent negative because you're not supposed to. All right, but here's the trick. You only want to move or flip what the exponent is on. So don't just start flipping the entire problem if the negative exponent isn't directly on the entire problem. So look at this. If they asked you to simplify these expressions, if they gave you x to the negative 3, guys, that's a done deal. There's nothing to do there, but you can't leave that as your final answer. So right now, anything that's not written as a fraction is assumed to be on the top. So if this is a negative exponent on the top, I got to move it to the bottom to make it positive. And now it's 1 over x to the 3rd. Because remember, your numerator can never be left empty. The denominator can be empty, but never the numerator. There's always going to be a 1 to placehold an empty numerator. And now that's a finished problem. All right, look here. If they gave you the expression 1 over x to the negative 5th, guys, there's really nothing for you to do. There's no power to power, or we're not multiplying. I just can't leave that as my answer. So if that's x to the negative 5th in the bottom, I got to move it to the top. So what happens is it becomes 1 times x to the 5th on the top. And then what is 1 times x to the 5th? Guys, it's just x to the 5th. You don't have to keep that 1. He was just placeholding the empty numerator. But once you move the x to the negative 5th up, the numerator's not empty anymore. And now that is your final answer. All right, look at this one. So we have a little bit more work to do, right? They want us to take 2 and times it with 4 to the negative 2. Well, guys, 4 to the negative 2, we can't do that. I can't times 4 by itself negative 2 times. So we got to move that. So really, this is going to be 2 times 4 to the negative 2. It needs to go to the bottom to become 4 to the positive 2. So it's going to be 1 over 4 to the positive 2. And now again, with a known value base, we can continue. So really, guys, this is 2 times 1 over 4 squared is 16, which is really 2 is over 1. 2 times 1 is 2. Over 1 times 16 is 16. And then 2 over 16 reduces to 1/8. But again, I didn't want to move the whole problem to the denominator because the whole problem wasn't raised to a negative exponent. Only the 4 was raised to that power of negative 2. So only that moved to the bottom. The 2 has no reason to move. All right, look at this expression. 3x to the negative 4. Guys, the negative 4 is just on x. If they wanted that negative 4 on the 3, then they would have had to put it in parentheses to include the 3. So without the parentheses, that negative 4 is just on x. So only the x needs to move. So 3 is going to stay in your numerator, and then x to the negative 4 is going to go to the bottom. And now that's a finished expression. Okay. So look here. Now, guys, now the whole problem is being raised to a power that is negative. So that means all of this is being raised to that power of -3, and all of it is assumed to be in the numerator. So we want to move all of that to the bottom, and now, guys, give it a positive power of 3. So the whole problem was raised to that negative exponent, so the whole problem went to the denominator, so now the numerator is empty, so we're going to need a 1 to placeholder. All right, so now we have to fix the denominator. A lot of times your directions on the homework are going to say, don't leave negative exponents and don't leave any parentheses. So we can't leave this. Guys, we got to do this. Think about it. Inside the parentheses, it says 2 times a. I can't multiply that together any more than it already is. So I look to the outside. That power of 3 says everything inside has to get that power of 3. So give that power of 3 to everything inside. So this is a 2, which is a number that we're going to raise to a power of 3. So guys, that's 2 to the 3rd power. That's 2 times 2 times 2. That's 8. And then when I take a and I give it that power of 3, that just becomes a to the 3rd. So it's 1 over 8a to the 3rd. And again, guys, if this part of the problem confuses you, then don't be afraid to expand it. 2a to the 3rd means 2a times 2a times 2a. And now you can see 2 times 2 times 2 is 8. A times a times a is a to the 3rd. So if that ever gets you, don't be afraid to expand it. Okay, perfect. So that's the 4th rule. Let's look at the 5th rule. That'll be our final rule. This one's the best rule because it's by far the easiest. Sorry, no problem. It's not a big deal. Do you need to answer it? Are you okay?
It's my sister.
You got go in the hallway. Go in the hallway. All right, here we go. So look at rule number 5, the 0 exponent rule. So guys, we all know math. He ain't nice, right? We already saw in a multiplying problem we add exponents. So you'd like to think that in a multiplying problem you could multiply exponents. It's just not how it plays out. So a lot of students, when they say the 0 exponent rule, they're like, oh, anything raised to the power of 0 is 0. It doesn't work out that way, and this is why. Think about what we know. Guys, what's 5 divided by 5? What's something divided by itself? 1. What's -24 divided by -24? Anything divided by itself is 1. So when you get to an expression like x to the 4th divided by x to the 4th, we don't even have to know who x is to know that when you take x to the 4th and divide it by himself, x to the 4th, what's the answer to this question? 1. Anything divided by itself in math is 1. But guys, think about this. In a division problem, what are you supposed to do with your exponents? You're supposed to do what? Subtract. So if I did my subtraction rule here, take 4, subtract 4, I would get x to the power of 0. So really, when you divide something by itself in math, you're getting an exponent of 0. And what do we know this is already equal to? We already know this is equal to 1. So therefore, by default, x to the power of 0 equals 1. So that means anything raised to the power of 0 in math equals 1. It means somebody divided something by itself to get that exponent of 0. So anything raised to the power of 0 will equal 1. You just got to figure out, all right, well, who is the 0 on? Is the 0 on the entire problem and the entire problem becomes 1? Or is the 0 only on a piece of the problem and just that piece becomes 1? I always say, whatever the 0 is on is gone, okay? All right, 8 to the power of 0. Well, guys, what's anything raised to the power of 0? 1. The answer is 1. X to the 4th raised to another power of 0. Guys, this power of 0 makes this 1. And even if you were to multiply your exponents together in that power to power situation, you would literally be left with x to the 4 times 0, 0. It's 1. Look at this. The entire problem, everything is raised to an outside power of 0. What does the whole problem become? 1. Anything raised to the power of 1 is gone. It's just 1 now. All right, look at this one. This is 6 times x to the 0 times y to the 3rd. Now, the 0 isn't on the whole problem. It's only on x. So 6 stays. You're timesing it with x to the 0, which is 1, and then you're timesing it with y to the third. Well, 6 times 1 is 6. Times it with y to the third is 6y to the third. So whatever that 0 was on is gone. That x is gone now. Just the 6 and the y to the third are left. All right, look at this example. -2 times 5 to the power of 0. That 0 is only on the 5. And PEMDAS says do exponents before you multiply. So this would be -2 times 5 to the power of 0 is 1. -2 times 1 is -2. Whatever the 0 is on is gone. Only -2 is left. All right, look at this one. The entire top, just the top, not the whole fraction, just the top is raised to a power of 0. So what does the whole top become? 1, and then it's still over 4, because you only get rid of what the 0 was on. And now look at this one. The entire fraction is raised to a power of 0. What does that whole fraction become? 1. Anything raised to the power of 0 is 1. It means somebody divided something by itself. All right, perfect. All right, so what I want to do now at home, can I get a thumbs up if you guys are okay with the last 2 rules? All right, are you guys okay? Good, and we remember them? We remember all of these rules? All right, let me show you a couple problems off Delta Math, and then I'll let you guys get out of here. So on your homework tonight, you're going to have a few problems on the negative exponent rule. There were no problems to assign on the 0 exponent, and then I'm going to give you a couple mixed problems where you might have to use 2 rules in order to get to your answer. So let me just show you a couple of them, and then we'll go. All right, guys, look at this problem. This is going to be something similar to your homework question. It says, express the following fraction in simplest form using only positive exponents. So we have to remove all parentheses, simplify the entire fraction, and not have any negative exponents in our final answer. All right, well, guys, ultimately, you still have to abide by the rules of PEMDAS. You have to follow PEMDAS. We follow him in calculus. We have to abide by those rules. Ultimately, this problem is asking you to take the top and divide it by the bottom. You're not dividing anything, though, until you get rid of the parentheses that are only on the top. So first, we have to simplify this. So think of this as its own problem. What's that going to become? Well, guys, inside the parentheses where PEMDAS would tell me to start, I can't do anything. It's just 3 times y to the 5th. Can't multiply that together any more than it already is. So I look to the outside, and there's this power of 3. That means everything inside has to get that power of 3. And since there's no adding and subtracting, I can just give it to everything inside. So do that. 3 is a number, and we're going to raise it to the power of 3. So guys, that's 3 to the third. 3 times 3 times 3, that's 27. And now think about what your rule says. Y to the 5th already has an exponent. When I give it another power of 3, that's a power to power. What do you do with your exponents? You multiply. 5 times 3 is y to the 15th. Now you can take that and divide it by the bottom. All right, so now it's a division problem. And we know we subtract our exponents in a division problem. And if you do the subtraction correct, you shouldn't end up with a negative exponent. All right, numbers first though. 27 and 2 are numbers, so the problem says to divide. So try to divide them. Does 27 divide by 2? No, it's odd. Does it reduce to a smaller fraction? No, so they stay. 27 over 2. Exponents, we subtract. Take the big one, 15, subtract 6 is 9, put it back where the bigger one was. And you're done. So you're done when you've removed all parentheses, you've simplified your fractions, and you don't have any, I'll say, like terms. You shouldn't have y's on top and bottom. You should only have y's in one spot now. All right, and type your answer in, and you're good to go. So 27, y. You use the little thing above the 6, the caret button on the 6 number, and that'll get you an exponent. But make sure you right arrow out of the exponent and then divide by 2. Awesome. All right, let me get you one with a negative exponent now. There's nothing in your mailbox. Nothing in my mailbox? No. Yeah, for somebody who never goes to their mailbox.
You're way less mailbox.
All right, let's do this one. All right, let's do this one and then I'll let you guys get out of here. All right, look at this one. So guys, if you noticed in the last question, we had to use the power to power rule and then we had to use the division rule. So it took 2 exponent rules to do that problem. So you might be using more than one rule. All right, watch this one. I have a negative exponent in the problem. I can definitely see that. But guys, I don't freak out. I work with the negative exponents. I'll add them, I'll multiply them, I'll subtract them. I just make sure that I don't have any negative ones in my final answer. All right, so again, ultimately, this problem is asking you to take the top and divide it by the bottom. But you're not dividing anything until you fix the bottom. I got to get rid of those parentheses. So we got to do the bottom. All right, so guys, right now you have 2h to the negative 3, a negative exponent. Don't freak out, don't worry. And it's all raised to a power of 5. Let's leave it. We can't get to them inside the parentheses yet anyway, so don't worry. So this says, since there's no adding and subtracting inside, everything inside has to get that outside power of 5. So let's do that. So 2 to the 5th. Guys, that's 2 to the 5th, right? 2 is a number. So 2 to the 5th is 2 times 2 times 2 times 2 times 2. That's 32. So now you got negative 10, h to the 6 divided by, that's 32. Now you have h to the negative 3rd. It's an exponent. It's a negative one, but it's still an exponent. And you're about to give it another exponent of 5. So what do? Power to power. You multiply. Guys, we can multiply negative numbers. It's okay. And you're going to get h to the negative 3 times 5 is negative 15. Okay, so we're ready. We can officially divide this problem. This is how I do it. Delta Math, if you look at their work or whatever, they might do it a little bit different. If you want to move the negative exponent now, you can. There's no adding and subtracting stopping you from moving that to the top. I don't like to do it because I'm afraid that you will do it when there is adding and subtracting and you're not allowed. So I just leave it. This is a division problem. So let's divide our numbers. What's negative 10 divided by 32? Guys, they don't divide, but they definitely reduce, right? Because 2 goes into both of these. Negative 10 divided by 2 is negative 5. 32 divided by 2 is 16. So that reduces. Okay. Now, what are you supposed to do with exponents in a division problem? You're supposed to do what? Subtract. So as long as you take the big exponent and subtract the little exponent, you'll always get a positive number. Watch. Who's bigger, 6 or negative 15? 6. So you take the big exponent, 6, and you subtract the little exponent, negative 15. What happens to minus minus? It'll always turn to addition. What's 6 plus 15? 21, and you put it back on the top where the bigger exponent was. If you do that correctly, you will always end up with a positive exponent, and the negative worked itself out. And that's how I do these problems. All right, type your answer in, and you're good to go. Negative 5h to the 21st. / the negative might stay out in front. It's perfectly fine, guys. Don't worry. Over 16. And you're good to go. Okay? So again, I tried to keep the problems I assigned you pretty simple. It only takes 1 or 2 rules to get to the answer. Tomorrow we'll start looking at maybe a few bigger examples. How do you guys feel? Is everybody okay here? Everybody's good? At home, are we okay? All right, awesome. So guys, you do have a homework on Delta Math. I think it's like 10 questions. It's due tomorrow night. Yesterday's problems are due tonight. Let me double check the attendance and I'll let you guys go. All right, if I say